thing I want to emphasize today is the idea of solving and checking so that you can immediately get feedback on problems. Now we're into the point of review for the final exam, and you're going to have problems to practice on. Hopefully, you'll spend a lot of time practicing in order to prepare for the exam. If you solve and check your work and it works out, then you know that you're solving it correctly. If you don't, if it doesn't work out, if your solution doesn't check, there are two possibilities. One, that your solution was wrong. Two, that your check was wrong. So you want to be very careful when you're checking so you don't get misled about whether your solution was correct or not. Okay, so we'll start with this equation. Now, this equation started with a quiz, and there are certain things that people tend to do that are just plain incorrect. Okay, for example, to try to add 6 to both sides to get rid of that 6, you can't do that, or that 6x, that 6, because that 6 is multiplied by 2. Adding 6 to both sides and getting rid of this thing, you're missing one of the negative 6's. It's got to be multiplied by 2 before you can move it to the other side, subtract it from both sides, or in this case, add it to both sides. So the first thing you want to do is you want to use the distributive law. Remember your order of operations. You multiply before you add and subtract. Multiply and divide before you add and subtract. Okay, so we multiply through by the 2 here. Now, I'm not going to do every step because I've done that a number of times, but we have 2 times 3x is 6x, and 2 times negative 6 is minus 12. And then we have plus 5. 3 times 4x is 12x, plus 21, then minus 3. And some people get in the habit of multiplying by 2 here, multiply the 5 by 2, but clearly you don't want to do that because the 5 is not included in what is multiplied by the 2. And similarly, the negative 3 is not included in what's multiplied by this 3. Now, I do say you want to write out intermediate steps. 2 times 3x minus 2 times 6. You want to write that out when you're solving it yourself to continue to reinforce the process, right? To continue to reinforce that you're using the distributive law and that you know what the distributive law says because it comes up again and again and again. All right, well, in any case, okay, so now what can we do? We need to simplify both sides. So I'm going to write down a few things here. We used the distributive law to get from here to here. And you want to write out the rules that you're using. Now we simplify. Now there are rules that we use there, mostly the order of operations. There's no multiplication in either of these sides. And no division. So we're into addition and subtraction. Now, some people want to do 6x minus 12. You can't do that because you don't know what x is. So you don't know how big 6x is, but chances are it's not equal to 12. So you can't, or it's not equal to 6 or whatever. You can't combine these two terms because this one has a variable value. Now you combine a 6x with a 12x in some way, but they're on different sides, so we're not going to do that. Because 6x and 12x will have the same value no matter what x is. However, 6x and negative 12, 6x doesn't have a fixed value and 12 does. You can't put them together. So we'll do the negative 12 plus 5, and it's going to give us 6x minus 7. And then similarly, on this side, you're going to have a 12x, and then 21 minus 3 is 18. Now we want to get our x's on one side and our numbers in another. And You'll see people say, we want to move this to the other side. I don't like the idea of moving things to the other side because people will, for example, if they don't want to have that -7 there, they just move a -7 onto the other side. I see it all the time. Okay, we have to follow the rules. So what we're going to do is we'll add 7. Just use them both in parentheses to the meaning to both sides. Well, the way we do that, the way people like to see that, because it's the way they're frequently taught, is we're going to add 7 to both sides. Now, writing it out the way I did, kind of looks like that 7 ought to be added to that 12, but that's not right. Okay, because again, we'd be adding 7 to 12x, and 12x has a variable value, 7 doesn't. You can't do that. Okay, so what I advise people to do here is 6x minus 7 plus 7. Write out this step. You can write out this step directly just by writing this side and putting a plus 7 on it, and then write out this side and put a plus 7 on it. But it can be helpful to add the equation 7 equals 7. Then 6x minus 7 plus 7 is 6x. 18 and 7 is 25. So we have 6x equals 12x plus 25. Now when I do this, I'm going to denote that sum equals sum. The sum of the left-hand sides equals the sum of the right-hand sides. Okay, now we simplify both sides, we get this. And then we want all our x's on one side, usually the left side. That's the way people are in the habit of saying it. Although you could have it on the right side and have the numbers on the left side. If that makes it happier, if you want to do that, if you're sure you're clear on the operations and what you're doing, that's okay. But in this case, I'm going to do it the way it's traditionally done. We add negative 12x. Okay. Both sides. That's a sloppily written both. It's a little look like a bath. But we do negative 12x equals negative 12x. And now we do the sum equals sum, meaning the sum of the left-hand sides equals the sum of the right-hand sides. And we get negative 6x equals 25 because the negative 12x and the 12x add up to 0. No matter what x is, these two things always have the same value. And these two things no matter what x is, they're multiples of the same x in every case. So we can do this. Okay, so there's sum equals sum, negative 6x equals 25. Okay, then we divide by negative 6, meaning, of course, divide both sides by negative 6. We get negative 6x over negative 6 equals 25 over negative 6. Simplify, negative 6 is the denominator and it's a factor of the numerator. We could rearrange this as negative 6 over 6 times x over 1 and see clearly that the negative 6's divide out, leaving us with just plain old x equals negative 25 over 6. Now, if you're wanting to graph the point where x equals negative 25 over 6, you're going to want that as a mixed number. And that's equal to negative 4 and 1/6. If all we want is a solution, negative 25/6 is just fine. You can also convert that to negative 4.2, 0.166 repeating. But in this course, usually we want to deal with fractions rather than decimals. Okay. So anyhow, here's our solution. Now, we want to check. We want to substitute x equals negative 25 over 6. And a lot of times, circle the solution. We'll narrow up here to the original equation. And a couple of x's in this equation. And that leads me to this. 2 multiplied by 3 times negative 25/6 minus 6 plus 5 equals 3 multiplied by 4 times negative 25/6 plus 7 minus 3. Might get a little hard to read. That kind of cut my negative 25 and my 6 with the parenthesis. It's too close. Try to squeeze things in here. But you can write this out yourself. Make sure it's correct. So what do? We first simplify. Okay. Now we can multiply 3 by negative 25/6, and we're going to get 3 times negative 25 over 1 times 6. It's negative 75 over 6 minus 6 plus 5 equals 3 times the quantity. 4 times negative 25, 4 over 1 times negative 25 over 6 is negative 100 over 6 plus 7, then minus 3. Now, the way you proceed from here, a lot of people go with common denominators and get all confused with that sort of thing. I don't like doing that. I don't recommend doing that. I'm going to recommend that you use the distributive law here. 2 times negative 75 over 6 is negative 150 over 6. 2 times negative 6 is negative 12. Add 5. 3 multiplied by both of these is going to be negative 300 over 6 plus 21 minus 3. I'm not going to deal with the fractions just yet, except I'm going to simplify. And write this left-hand side as negative 150 over 6 minus 12 plus 5 equals and rewriting what I had. Negative 12 plus 5 is negative 7. 21 minus 3 is plus 18. Now you might notice that 150 over 6 divides out and gives you negative 25. Negative 300 over 6 divides out and gives you negative 50. and that's going to check out. To illustrate the way I want you to use fractions, though, if you don't see that, and of course you could have seen that the negative 75 over 6, negative 100 over 6 themselves simplify. But if you haven't seen that, and in general, it might not happen. You might end up with a fraction here and a fraction here. So multiply by CD, which means a common denominator. So we're going to have six times negative 150 over 6 minus 7 equals 6 times negative 300 over 6 plus 18. The distributive law tells us that this is 6 times negative 150 over 6 plus 6 times negative 7 on the left-hand side, and 6 times negative 300 over 6 plus 6 times 18. And my 18 isn't coming out very well. Yeah, that one's not too bad. Multiplying fractions, it helps to make the 6 into 6 over 1. The 6 that's multiplied by both sides here and here. To see clearly that we have a 6 in the denominator, and 6 is going to be in the numerator. And this gives us just negative 150 minus 42. And the 6's divide out here. And we get negative 300 plus 108. That gives us negative 192 equals negative 192. And we put a big check mark there. Every detail worked out correctly, but you see there are a lot of details, especially when we have a fraction or a solution. Now, if we didn't have a fractional solution, a lot of these steps would have been unnecessary, and this simplification would have been more straightforward. But you should be able to solve a linear equation, no matter how complicated, by simplifying it and following the usual steps and checking your solution. Again, if you're reasonably adept with fractions, it would certainly be legitimate to simplify this negative 75 over 6 to negative 25 over 2, or the negative 100 over 6 to negative 50 over 3. However, again, I wanted to illustrate how multiplying by a common denominator clears out all your denominators, gives you just plain old simple expressions. And that works when you have a denominator and an equation as well. Okay, well, let's look at an example. We have denominators and equations. Sticking for now with linear equations, let's say we have 5 over 3x plus 8 equals 4 over 5x minus 3. How do we deal with this equation? Well, immediately we see that we have denominators. We don't want denominators in an equation. It complicates things. So we multiplied by a common denominator. Now the common denominator here is going to be 15x because 15x is a multiple of 3x. 5 times 3x is a 15x. And 3 times 5x gives us 15x. So 15x is divisible by both of these denominators. So we do 15x times 5 over 3x plus 8 equals 15x times 4 over 5x minus 3. Multiplying both sides by the 15x. Applying the distributive law, we get 15x multiplied by 5 over 3x plus 15x times 8. I'm not leaving myself enough room, so let me start over here. Yeah, 15x times 5 over 3x plus 15x times 8. Now, 15x here multiplying, we want to go ahead and put a 1 here so we know that we can multiply the numerators and multiply the denominators. There's still some confusion on that idea. You might or might not be confused by that. If you aren't, well, all I can say is be careful. Then we're going to have 15x multiplied by 4 over 5x minus 15x times 3. And we're going to put a 1 here since we're multiplying fractions. So multiplying a fraction by something that doesn't have a denominator, we give it a denominator of 1 because 15x is exactly the same as 15x divided by 1. We multiply these numerators and we get 75x over 3x plus 120x equals 15x times 4 is 60x over 5x minus 45. 75x divided by 3x incidentally, I should have written distributive law here. I want you to follow the form that I'm using here. 75x over 3x is just 25 because the x divides the x, the 3 divides the 75. They're both factors. X is a factor of both numerator and denominator, so it divides itself, leaving 1. 3 is factor of the denominator and the numerator. 3 divides 75, giving you 25. Okay, 60x divided by 5x, very similarly, gives you 12. 12x. Be careful. See that I almost made a mistake there. Okay, 12x minus 45. Now, add negative 25 to both sides. We'll put negative 25 equals negative 25. You might want to align the 25s with the numbers they're going to add to. But if you do, as I recommend, and write this now as 25 plus 120x minus 25. Saying that the sum of the left-hand sides gives you this, The sum of the right-hand sides gives you 12x minus 45 minus 25. We can now see clearly that the negative 25 is going to be subtracted from the 25, leaving us 120x. And the negative 45 and negative 25 will be combined. That's negative 12x minus 70. It's not negative 12x, it's 12x minus 70. And I've got mistakes here that I need to apologize for. This is not 12x, but 15x times 3 is 45x. The x goes here. So that what I end up with in this step is negative 13 minus 45x. Okay. I was just very careless when I put an x on that 12. I wasn't looking clearly at where that 12 came from. And I didn't put an x here, where obviously negative 15x multiplied by 3 does give me negative 45x. When I got down here, I was getting silly numbers. So I recognized it. Now, had I not recognized it, then when I went into the check and it didn't work, I'd have had to go back and find my error. And so in any case, I'm still adding negative 25 to both sides here. The 12 and negative 25 gives me negative 13, and I still have my negative 45x. So negative 120x remember, I want to write down this side. I don't want to add the 12 and the negative 25 here. I want to write out this side minus 25 here, and this side minus 25 here. Then when I do that, I get 120x equals negative 13 minus 45x. Then I had 45x, both sides. So I'm going to put 45x equals 45x, which is going to give me 165x here. And I'm sorry, let me stick with my procedure. Gives me 120x plus 45x equals negative 13 minus 45x plus 45x. The negative 45x and the plus 45x give me 0. So the right-hand side is negative 13. Left-hand side is 120x and 45x, which is 165x. I'll denote this step as sum equals sum, and I'll denote this as simplify, because I'm just adding the negative 45x to the 45x, and 125x to the 45x. So that finally, x equals negative 13 over 165. Now again, we get a fraction down here. And we're going to have to substitute that fraction back in to the original equation in order to check. which we do by substituting x equals negative 13 over 165 into the original equation. And this, again, gets a little complicated. We want to go step by step, keep it as simple as possible. So we have 5 divided by 3 times negative 13 over 165 plus 8 equals 4 over 5 times negative 13 over 165 minus 3. Now we have to use a little bit of our knowledge of fractions. Okay, first of all, we simplify the denominator by multiplying 3 times negative 13 over 165. And then 5 times negative 13 is negative 65 over 165. Now we have 2 complex fractions. This fraction means 5 divided by negative 39 over 165. This means 4 divided by negative 65 over 165. Well, let's write it out. That's 5 divided by negative 39 over 165 plus 8 equals 4 divided by negative 65 over 165 minus 3, which is the same as 5 times negative 165 over 39 plus 8 equals 4 times negative 165 over 65 minus 3. Now we find a common denominator for 39 and 65. I'm going to scratch it down over here. "39 is 3 times 13. 65 is 5 times 13. Common denominator would be 3 times 5 times 13. Because the common denominator includes the 3. I don't know why I wrote 16. I'm pretty sure I said 13. And it contains the 13. It also contains the 5 and the 13 from 65. Okay? So that 3 times 5 times 13 is your common denominator. I almost want to leave it in that form because what we're going to get here is 15 times 13. I think it's 195. Let's see if I divide that by 3, I get 65. Divide by 5, I get 13. Yep, that's going to be right. Well, multiply by the common denominator. Now the numbers are getting a little bit ridiculous here, but I want you to understand if you keep your wits about you and follow the steps, you can do this. Now, I could multiply the 195 by the 5 and then multiply that by negative 165. But I'm actually going to write this as careless and not putting parentheses here. The 195 multiplies this. 195 multiplies negative 3. And if I've done everything correctly, well, 39 goes into 195 5 times. Now I'm sure you're about to go blind and this is getting really too complicated, but 39 goes into 195 5 times. And 65 goes into 195 3 times. And we have this series of numbers, which you can then multiply out with your calculator if you wish. And they should come out the same on both sides. Now, I can risk multiplying these numbers. 195 times 8 would be 1600 minus 40 is 1560. So we get here, 195 times 3 is 600 minus 15, which is 585. Okay, now, what's 25 times negative 165? Well, I think that's 4,125. Over here, 12 times negative 165 is, oh heavens, going to make me multiply that. Okay, it's negative 1650 and 330. I think it's negative 1995, which is a good year. Okay. Now, do those add up? Negative 1995 and negative 585. should be pretty easy to add up. That's going to give me negative 2510. And this isn't going to quite work out. In the first place, that can't be negative 1995. Okay, so let me remultiply that. I get negative 1650. That should be 85. Still not going to be very helpful. Okay. Well, my mental arithmetic is a little bit faulty here. This appears to give me, on the left-hand side, negative 20. Or 65. Okay, my brain is, I think that's 25, 65. And negative 2510. So I did something wrong with at least one of these multiplications. But you have a calculator in your hand and calculate these things accurately and see if they work out. These are close, so I'm not sure where I went wrong with my arithmetic, but it's still questionable whether this is a correct solution. Now, this becomes a real mess with the numbers, but again, the point I want to make here is that if you keep your wits about you, you're going to be able to complete the check and determine whether you've got this right or not. I'm not going to give you an equation like this on the test. It'll be much simpler, but if you can understand what we did with the fractions here, then you can understand how to conduct the check. And the fractions are a little simpler. Here's a quadratic equation, and we're going to attempt to solve this by factoring. Now go ahead and solve it as usual before you see me do it. In any case, we can factor this particular quadratic. Get x plus 3 times x plus 4 equals 0. And then we use the zero property of multiplication. It's good to give this a name, and it just means that if two things, if the product of two things, if you multiply two things and get 0 for the product of 0, then one of those things has to be 0. Which means that we can split this into two equations. X plus 3 equals 0 or x plus 4 equals 0. It's not x plus 3 equals 0 and x plus 4 equals 0 because x plus 3 can't equal 0 if x plus 4 equals 0. It's got to be 4. One of these is 0. They can't both be 0 for the same value of x, which is why we use the word or. Well, this is easily solved. Add negative 3 to both sides, and I'm not going to write that out. Get x equals negative 3 or x equals negative 4. The solution set is set -4, -3. Now we check. We substitute x equals -4. Now we say we substitute that into the original equation. We get -4 quantity squared plus 7 times -4 plus 12 equals 0. So that's 16 minus 28 plus 12 equals 0. If we add this all up, 16 and 12 is 28, and -28 gives us 0 equals 0. So that checks. And then substitute x equals -3. Get -3 squared plus 7 times -3 plus 12 equals 0. -3 squared is 9 minus 21 plus 12 equals 0. 9 and 12 is 21. Minus 21 gives me 0 equals 0. So we check this. Now let's try another one. Let's, instead of 7x, or instead of 12, let's make this 5. Okay. We try everything in the world. We try to factor this, but no luck. We can try x plus 5 and x plus 1. That would give us x squared plus 6x plus 5. That's about the only thing we could try. Now, there could be rational factors, but we're not going to get into that until the pre-calculus course. Okay. So we're going to use the quadratic formula. Now, the complete reasoning, this is of the form ax squared plus bx plus c equals 0. And I recommend you write this step out, telling yourself what you're doing at every step until it seeps in and becomes second nature to you, and you don't forget it. Okay. It's of the form ax squared plus bx plus c. If a equals 1, b equals 7, c equals 5. So solutions are, or solution is, or maybe there's no solution. We have to figure that out. But what do we get for solutions? Solutions are x equals -b plus or minus the square root of b squared minus 4ac all over 2a equals, well, b is -7. B is 7, so we get 7 squared. Then it's minus 4ac, a is 1, so a is 1. and C is 5. And we do the arithmetic. And you should be stopping and doing the arithmetic before I do it. Okay, 7 squared is 49 minus 4 times 1 times 5 is 20. And there are our two solutions. And just to be explicit, plus or minus square root of 29 means you could have negative 7 plus the square root of 29 over 2, or negative 7 minus the square root of 29 over 2. Now, the square root of 29 turns out to be about 4.3, 5.3. So that approximate solutions are this: negative 7 and 5.4 is negative 1.6. So one solution would be negative 0.8. In another solution, negative 7 minus 5 is negative 12, so we get negative 12.4 over 2, which is negative 6.2. Now, these aren't exact. Square root of 29, if you put it into your calculator, it'll give you as many decimal places as your calculator has room for, because this is an irrational number. It can't be expressed as a decimal exactly, because it keeps going forever. And it can't be expressed as a fraction because that decimal never repeats. Okay. But we can plug these numbers into the original equation. Now, I'm big on doing these checks, but all I'm going to say is, okay, you got negative 6.2, you square that, and you get something a little less than negative 40. This gives you something a little more than 42, which gives you something a little less than 40, something a little more than 42, a little less than 40, around negative 42 or negative 43, and you add those together and you get something around negative 5, and it works out. If you have 0.8, 0.8 squared is about 0.64. That's about 5.6. And those numbers add up to about negative 5 and give you 0. So you can plug these numbers in and get 0, and the solution is pretty straightforward. Okay, well, it's an example of the use of the quadratic formula and a check. Let's do one more equation with a quadratic. Three x equals x squared plus 5. How are you going to solve that? You should have made an attempt. Point is, this is quadratic. because it has x squared x in constant terms and no others. You might recognize that I can simplify this equation. Or I can rearrange this equation. It's not necessarily simplified. You put this into the form ax squared plus bx plus c equals 0. We start with 3x equals x squared plus 5. We need to get 0 on one side. I'm going to choose to subtract 3x from both sides, or at least add negative 3x to both sides, and that's going to make the left-hand side 0. And we're going to then have x squared plus 5 minus 3x. And let's write it out, as I keep urging you to do, forgetting to do myself. Okay, so we add negative 3x to both sides. Sum equals sum. So 3x minus 3x then is 0. Because what we're going to do is simplify. And we're going to write this side as x squared minus 3x plus 5. And then if this is equal to this, the two sides are equal. We can switch sides, giving us x squared minus 3x plus 5 equals 0, which we're going to easily solve using the quadratic formula. Now, there's an alternative here. We could do negative x squared minus 5, negative x squared minus 5. No, there's subtracting x squared plus 5 from both sides. And we would get negative x squared plus 3x minus 5 equals 0. And this is an alternative. Well, we can see that this equation is the same as this equation, except that every sign is reversed. We have x squared here, we have negative x squared here, we have negative 3x here, we have plus 3x here, we have plus 5 here, minus 5 here. So if we multiply this equation by negative 1, we get this equation, which might be preferable. Because if we apply the quadratic formula here, we get A equals negative 1, B equals 3, C equals negative 5. We have a couple of negatives in there, where this one only has one negative, and it makes the quadratic formula a little bit simpler. But if you're careful, you can use a quadratic formula and solve it like this. So if you rearrange an equation like this, it really doesn't matter how you rearrange it, as long as you get 0 on one side using valid operations. adding the same thing to both sides. I'm going to continue to solve here. And I recommend that you write this down. You remind yourself that this is of the form ax squared plus bx plus c equals 0. And then you identify the values of a, b, and c. One thing it prevents, if you do this, if you try to solve this equation without recognizing that it's quadratic, well, you're never going to get this form, are you? Okay. If I try, for example, to subtract 5 from both sides, I end up with an x squared on this side, an x on this side. It gets me nowhere unless I invent an invalid step. So we want to be sure we recognize that the equation is quadratic in the first place so that we can go through this entire process. Okay. So we get x equals negative of -3 plus or minus -3 squared minus 4 times 1 times 5, all divided by 2 times 1. And we can evaluate this without doing the arithmetic. We get 3 plus or minus the square root of, that's going to be 9, and that's going to be minus 20. And at this point, we realize that there's no solution, no real solution, because we've got a -11 under the radical sign. I'll just write square root of a negative. Okay, so that's how we could solve the equation of this form. Now let's look at another equation. Which I'll solve rather quickly. We don't have time left to do a check. Let's just take 5 over x minus 3 plus 7 over x plus 4 equals 12. In order to solve this equation, we want to multiply by a common denominator. CD stands for common denominator. And that's going to be x minus 3 times x plus 4. Now, we saw in a check just a little while ago how complicated it can be if you're multiplying by a common denominator, if your numbers are uncooperative. When you have symbols, usually it's a lot simpler, actually. So we multiply x minus 3 times x plus 4 times 5 over x minus 3 plus 7 over x plus 4 And on the other side, multiply the 12 by the same thing, x minus 3 times x plus 4 times 12. On the left-hand side, we get x minus 3 times x plus 4 times 5 over x minus 3 by the distributive law plus x minus 3 times x plus 4 times 7 over x plus 4 equals, if we multiply x minus 3 by x plus 4 using the distributive law, we're going to get x squared minus x minus 12, and then that itself is multiplied by the 12 that I already have on this side. And I'm not going to go through the details of multiplying this binomial, but you need to do that in 2 steps using the distributive law. Okay, not using this thing, which is equivalent to the distributive law. We want to reinforce the distributive law and go through the steps until you're very, very secure with the distributive law. This is kind of a shortcut and gives you the same thing. And it's okay as long as you can use the distributive law where it's needed. All right, in any case, well, I'm going to put this as a fraction over 1, and it's not lined up very well, but we understand what we're doing, and we get x minus 3 times x plus 4 times 5. That's going to be the numerator, and the denominator is x minus 3. Here we're going to get x minus 3 times x plus 4 times 7 over x plus 4. Now we can multiply the 12 through this quadratic expression. We're going to get 12x squared minus 12x minus 144. Now it looks like it's going to get pretty messy, but look here now, the x minus 3 divides the x minus 3, leaving us x plus 4 times 5. The x plus 4 divides the x plus 4, giving us x minus 3 times 7. And that equals the 12x squared minus 12x plus 144. Using the distributive law here, we get 5x plus 20 added to 7x minus 21 equals 12x squared minus 12x plus 100 minus 144. Look at what I did. Let's fix that. 5x and 7x gives us 12x. 20 and minus 21 gives us minus 1. Gives us 12x squared minus 12x minus 144. Now notice that by this step, all our denominators are gone and everything is really pretty straightforward from this point on. We just simplify the left-hand side, which we've done. It simplifies down to 12x minus 1. Right-hand side is the quadratic expression 12x squared minus 12x minus 144. So that multiplying by this common denominator, which is actually quite easy to do, if we're just careful and understand that factors of the denominator divide factors of the numerator, equal factors of the denominator and numerator essentially cancel out. I don't like that word. But that's what happens. Okay, so that this smooths the whole thing out where we don't have the denominators. We don't have to find common denominators. We don't have to mess with rational expressions. Okay, well, if we but what we want to do at this stage is we want to recognize that this is quadratic. This equation, this whole equation here is quadratic because what's the condition? We have nothing but x squared x and constant terms. That's our test. If so, we can do this. We get 0 then equals 12x squared minus 24x plus 143. Or if we want to write it in the standard form, we get this. This is a x squared plus bx plus c, where a equals 12, b equals negative 24, c equals, this should be minus 143, be very careless. C equals negative 143. Well, you're going to get a solution, but you're not going to get a nice square root, okay, which means you're going to have to approximate the solution and take that approximate solution, plug it back into the equation. You'll end up probably using your calculator to do this in order to check this. Okay. Okay, well, we're out of time. We're a little over time, so I'll let you go and we'll continue some reviewing next time.